I wanted to give you a chance to do a little bit of practice sort of putting it all together. So these are 2 practice questions for you to try. For the first practice question, we're using our data set called assembly line. And essentially that's giving us weeks that an employee has worked at the lawn mower assembly company and time it takes to assemble a lawnmower. So here are some questions based on that, so you can load that data into Excel or into Statcrunch to help you perform your analysis, or of course enter it into your calculator. And once you are done with that question, I want you to also try question number 2, which is dealing with Olympic long jumps data. And again, there are some questions for you to answer as well. So I would like you to try both of those. Take your time. Be careful on practice question 2. We're going to throw a little curveball into that one. And then press play to check your work. For the first question, we have the production manager of a lawnmower assembly line believes that the longer an employee works for the company, the less time it takes for the employee to complete the assembly of a mower. Hopefully that's the case. So we have 2 variables here, which is of course weeks that the employee has worked there and time in minutes that it takes for the employee to complete the assembly of a mower. And the first question is, which is the response variable? And so we're assuming that response variable would be time that it takes to complete the assembly of a mower. Question 2, what is the correlation between the variables? So what does that mean? That means that we're looking for our R and our R squared. So R squared in this case was 93.77, which is our correlation. The correlation coefficient of R is good to know because notice here that it is negative. And how did I find that? I let Statcrunch find it for me. So negative 0.968 is my R value. The fact that it's negative means that my trend line is negative, my least squared regression line is negative, going down from left to right. Now we're going to check the conditions, and here is the scatter plot that I created in Statcrunch, and here is the residual plot. So to check the conditions, again, I would check the quantitative variable condition, which I already did. Straight enough condition, clearly this does look straight enough to me. Outlier condition, I don't see any outliers. And does the plot thicken? There is a little bit of a pattern, but we don't have that many data points, so it's kind of hard to tell. It might be a good idea to create a residual histogram, which you can also do in Statcrunch. What is the regression equation? Again, I'm allowing Statcrunch to do that for me. It is time hat equals 42.067 minus 1.812 multiplied by weeks. And then of course we're going to use that model to predict. So to predict someone in her 12th week, we would just put 12 into this equation, and I found 20.32 minutes. But the question says, should we trust that prediction? Why or why not? On this one, I would be a little bit leery, not only because I wasn't quite sure on my residual plot, but notice I only have time through 10 weeks. So 12 weeks is actually extrapolating beyond the data, so we don't know that once they hit to 10 weeks, maybe their times stay constant. We don't know what's going to happen. Maybe they start going back up again because they get lazy. We don't know. So be very careful when we extrapolate. For our second question, we are looking at long jump distances over the years. And essentially what we're looking for is there a trend in the long jump distances? So before I go into any of the questions, I want to look at Statcrunch. So in Statcrunch, I have all of my data that I've already pasted in. And if I go to Stat and Regression and Simple Linear, choose my 2 variables, and I do want to see the residual plot on this one as well. So I've got my fitted line plot, and I also have my residuals versus X values and compute. So this gives me a lot of that information. And here's the scatter plot, and then of course here's the residual plot. So looking at the scatter plot, especially knowing that I'm going to try to predict in 2015, this area is a little bit concerning for me because it seems that I've got sort of an upward trend, but then it goes down and then up and then down, and then wow, from here on out it's decreasing. So even though my line of best fit seems to be increasing as I go, it seems that in the end here I'm decreasing quite a bit, and that scares me. So instead of using that regression equation, I'm going to choose the values, say starting from 1988, because notice that's when those values start to decrease. So I'm using just 1988 on, and it's okay to use that partial data because this is the trend that's happening now. So now if I go to Stat and Regression and Simple Linear, I'm going to choose var4 and var5, and then I can use the fitted line plot, and of course the residuals, and compute. And that changes things dramatically because now I have one that's decreasing and then a residual plot here as well. So again, that's one way that you can handle it if you find that when you make your scatter plot that maybe it's not fitting the data quite the way you wanted it to. So yes, of course, the response variable is the jump distance. The correlation is 75%. It's actually 0.798 when I did just that second part of the data. So, and then my R value actually changed from positive to negative when I did that. So this is my first R value and correlation. And then if I go back to Statcrunch, I can see that my new R squared value is 0.798 and my new R value is a negative 0.89. Now, based on this new data, I can say that initially it did not seem to be appropriate, but now we're using this new data, and they're both quantitative, year and distance. The straight enough condition, again, we don't have a ton of data points, but it does seem to be going in a negative linear direction. I've got some issues in here, possibly. It's difficult to tell if it's straight. The outlier condition, I don't really see any outliers. Does the plot thicken? Again, there's not a ton of data points here, so it's kind of hard to tell. We might be concerned about the fact that it sort of goes up here and comes back down. It's really hard to tell with so few data points. You can also create a residuals histogram, and if that's unimodal and symmetric, we can use that for our residuals as well. The regression equation, after we changed to just this smaller data set, is jump length hat equals 40.669 minus 0.016071 multiplied by year. Using the year of 2016, we would find 8.33 meters. Again, because the conditions, we're concerned about two conditions, and again, we're extrapolating past the data that we have, which looks to go through 2013 or so. We should be a little bit wary of our results.